Rn. So what this theorem is stating, any two-terminal network, as if Thevenin's theorem, any two-terminal network can be replaced with a current source in parallel with Rn. So this is your current source. So this is your current source. So this is your current source, and this is your Rn. So any network can be replaced with a current source in parallel with Rn. What that is Norton's theorem. Where what is current source? Current source is nothing but it is the short circuit current through the terminals, and Rn the input equivalent resistance. Suppose if you have a network like this, and you have two terminals A and B, and you have removed the element between A and B. Okay, the equivalent resistance seen from these two terminals A and B into the network is called Rn. So Rn is nothing but it is almost equivalent to RTH. Okay, now you short these two terminals A and B, and some current will be flowing. That current is called ISC. So that ISC, the short circuit current, is nothing but your IN. So IS is equal to IN. Okay. Now across the two terminals, if you calculate the voltage, suppose this is A, this is B terminal, and across to these two terminals, if you calculate the voltage, that voltage we are calling it as VOC or is equal to VTH. Okay, VOC or VTH. Now, what is the relation between VOC, VTH and ISC is VOC is equal to RTH into ISC. VOC is equal to RTH into ISC. This is one relationship. Okay. So this ISC is nothing but your IN. So whatever the circuit is given, you are going to convert that entire circuit into a current source in parallel with resistance. Current source in parallel with a resistance. Okay. So we will do one problem on this so that you will understand better. So here 2 ampere source is there. Okay, here 2 ampere source is there, and 12 volt source is there. 12 volt source is there, and these are the two terminals A and B. Okay, so what he is asking you to? He is asking you to find the Thevenin's resistance Rn. Find the Thevenin's resistance Rn and IN. So you have to find Rn and IN. So for that, what I am going to do is I am going to solve it in a fresh page. Okay, so 2 amperes. So this is your 2 ampere source. Okay, this is your 2 ampere source, and 4 volts, 4 ohm source is here, and we have a voltage source here. Okay, we have a voltage source here, and 8 and 5 are connected. 8 ohms and 5 ohms are connected like this, and here across this 5 ohms it is a open circuit. Okay, so this is a 2 amperes, 12 volts, 2 amperes, 12 volts, and 4 ohms. Now he is asking you to find Rn and RTH. So the first step is to find Rn. Okay, first step we will do Rn. So to find Rn, what you have to do? We have to open the current source and close the or short the SHOT, short the voltage source. How many voltage sources are there? One voltage source, so you have to short it. And how many current sources are there? One current source, you have to open it. Then the circuit will become like this. This is 8 ohms, 4 ohms, and 5 ohms, and this is short circuited. This is Sorry, this is open circuited, right? So this is open circuited. Okay. Now you want to know what is the resistance between the terminals A and B. So this is 5 ohms and this is 8 ohms and this is 4 ohms, right? 8, 4, 1, okay. Now, how 8 and 4 are there? 8 and 4 are in series, so 8 plus 4, that is equal to 12 ohms. Okay, and 12 and 5, how are there? They are in parallel. So 12 into 5 divided by 12 plus 5. How much it is? Can anyone calculate and tell me? Oh, sorry, I have forgotten one 8 ohms resistance here. So here 8 ohms resistance is there. So here one 8 ohms resistance is there. So 8 plus 4, how much? How much? 8 plus 4, 20 ohms. So 8 and 4 are in series. So you add them. 8 plus 4 is 16 plus, sorry, 16 plus 4 is 20. And that 20 ohms, which is in series, is in parallel with 5 ohms. So 20 into 5, 20 into 5 divided by 25. 20 into 5 divided by 25, which gives 4 ohms, which is your Rn, which is your Rn. Now you have to find In. You have to find In. So to find In, what you have to do? You have to short these two terminals A and B. You have to short these two terminals A and B and find the current that is flowing into this circuit, ISC. Okay, when you short these two terminals, what happened to this 5 ohms resistance? Since the short circuit will have very low resistance, no current will flow into the 5 ohms resistance. So this will be your 4 ohms resistance, and this will be your 8 ohms resistance, and this is your 12 volts, and this is your 2 amperes. Okay, this is your 2 amperes, and this 5 ohms is short circuited. So you have to draw like this. Okay, that means if you could able to find the current in this 8 ohms resistance, that is your ISC. That is your ISC. Why I have not written this 5 ohms means the current coming from this 8 ohms. Okay, we'll see this short circuit path, and the entire current will go into this. So no current will go into this 5 ohms resistance. Now, if you apply KVL in this loop, let I1 is the current flowing in this, and I2 is the current flowing in this, and I2 is the current flowing in this. Then this is 2 amperes. So I2 is equal to 2 amperes. I2 is equal to 2 amperes, and minus 12 plus 4 I1 minus I2. What is I1? What is I2? I2 is 2. Okay, plus 8 I2, 8 I1 is equal to 0. Okay, so minus 12 plus 4 I1. Okay, minus 4 to 8 plus 8 I1 is equal to 0. So minus 12 minus 8 minus 20. So you send that to 4. So 12 I1 is equal to 20. So I1 is equal to 20 by 12. I1 is equal to 20 by 12. So that I1 which we have calculated is 20 by 12, which is your ISC, How much is 20 by 12? 2 tens. 1.6. How much? 1.6. 1.66 amperes. 1.66 amperes is your ISC, which is equal to IN. So if you want to draw the circuit, that Norton circuit, so Norton circuit will be like this: a current source and a resistance will be in parallel. Current source and a resistance will be in parallel. So what is this 1.66 and what is this Rn? Rn is 4 ohms. So across A and B, now you have found the Norton equivalent circuit. So this is your Norton circuit. What we call this as Norton circuit. Norton circuit. Okay, this is your Norton circuit. now, now I have